Alright, so in this video we're doing work energy questions, so you're more than welcome to pause the video and attempt the problems by yourself, right? Good, let's get into it. So the question statement reads as follows. A 70 kilogram box is initially at rest at the bottom of a rough plane, okay, inclined at an angle of 30 degrees to the horizontal. Now the box is pulled up the plane by means of a light inextensible rope held parallel to the plane as shown in the diagram below. Now the force applied to the rope is 700 newtons. Now the first question being 5.1, what is the name given to the force in the rope? Now 5.1, they want to know the name of the force given to the rope, which is what? Tension, right? So this is because the rope is associated with what? Tension force. So now 5.2, give a reason why the mechanical energy of the system will not be conserved as the box is pulled up the plane. It's because of this rough, and the reason it's because there's friction, right? There's friction in the system. That's the answer that you can give. Moving on to 5.3. Now 5.3, the box is pulled up over a distance of 4 meters along the plane, right? And the kinetic frictional force between the box and the plane is 178.2, okay, 0.22 newtons. Now the first question reads, draw a free body diagram as it moves upwards the plane. Okay, so the free body diagram, as I always say, please draw this free body diagram with components. It's gonna help you a lot. So we've got the tension, we've got the normal, we've got the weight of which we're gonna draw it in its components. Right, so like this. Good, I think it should be much better. Right, the reason for the components, I always say, it will help you a lot in your calculations. So this is the tension, this is the normal, this is FG perpendicular, FG parallel, and the last one being what? Friction, FK. Good. So yeah, 4. 1, 2, 3, 4. Yeah, it's 4. Calculate the work done on the box by the frictional force over the 4 meter. So they want us to calculate the work done on the box by the frictional force over the 4 meter, of which this can be what we can say work done is equals to F change in X cos theta, of which in this case, what is the frictional force? The frictional force is 178.22, and the change in X, the distance of which it moves along, it's 4. So not 40, it's 4, and this is what cos 180 because it opposes the motion, right? Our answer then is supposed to be negative 712.88 joules, right? Good. 5.5, it says use energy principles to calculate the speed of the box after it has moved 4 meters. Okay, so they want us to calculate the speed of the box as it has moved 4 meters. So we haven't defined anything in this question, which is so odd, but then it's fine. So what are we gonna use? I do recommend us using the non-conservative force formula, change in EK plus the change in EP, right? I think it will be much better. Because our non-conservative forces in this case, it's friction and tension, right? So we have those two, and plus this is potential energy from the lower ground to the upper ground. I think will help us a lot. So from there on, what can be said, it's the work by the tension plus the work by the frictional force and the change in EK plus the change in EP, right? Good. Now from there on, what do I know about the tension? The tension, I know that 70 oh sorry, it's the force applied to the rope. Okay, so the tension, basically we have been given it. In most instances we have to calculate the tension, of which it's 700. So I'm gonna say 700 multiplied it by 4 multiplied by cos 0, since it's in the positive direction that we want, then plus the weight. Now not the weight, by the way, the work done by the frictional force, which we have calculated already, which is negative 712.88 joules. And we can come on this side. Now the mechanical energy or the potential energy, we are going to say 70 times 9.8. Now the height difference, right? 70 times 9.8. It's going to be what? This is where you have to use your trig, because this is what? This is 4. Now we don't have the height. Now you have to find the height. Now the height is going to be what? It's going to be sine something, right? Alright, so we're going to say sine 30 is equals to, let's just say it's x over 4. So x is basically 4 times sine 30 degrees, right? So that's the height from that point, right? So since we're starting from here and we go here, our height it's what? It's going to be multiplied by 4 sine 30 degrees minus 0, right? This is the final one and this is the initial one, and we're going to say plus 1 over 270 since it's m, right? Yeah. Oh, let me change here because it's EP EK, but it's fine. You get what I'm saying. EP EK. It's because of the way I've written it already. All right. Now, what can I say? It's 70 multiplied by the VF that they want, that point up, minus the 0. So the VF after simplification, after you simplify here, we're gonna find what? The 4.52 meters per second. So this is our answer for 5.5, right? Now moving to the last one, which is 5.6. Okay, before I even move from this one, the confusion may be which one would you use, right? But then of which it's okay. If you get the same answer as me and you used any method that any formula that you used, you're most definitely correct. Some may have used the network. It's equal to the change in kinetic energy, of which summed all of the forces from the friction, the gravity, the work done by gravity, the work done by the tension, and yeah, they would have done that, of which it's also okay. There's no problem with doing that. Yeah. So now 5.6, it states when the box is 4 meters up the incline, the rope accidentally breaks. Oh, really? Causing the box to slide down to the bottom of the inclined plane. Now, what will be the total work done by friction when the box moves up and then down to the bottom of the inclined? This is an interesting question, though. So, what will happen here is, remember that friction is trying to oppose the motion of the box. Now, say for instance it just breaks. Now, friction, what will it do as it slides down? It will also double in its effect because now it's moving down and there's nothing holding it from moving downwards. So basically the answer here, we could just say the frictional force, the total work done by the friction, it's going to be 2 times negative 12.88. It's equals to 1425.76 joules. This is basically what you can say for this case. You just double the frictional the work done by the friction in 5.4, right? Right, so just like that, we're done, and I hope this was an interesting question. By the way, it didn't have the definitions and stuff. It was an interesting question, I won't lie. So I hope you understood, and if you have any inquiries, please leave them below or email me. And just like that, guys, I will see you in the next one.